CFD, and also you can have your scale model in the third stage. Okay, so you can accelerate your development and also decrease the cost of your development, especially for some innovative eVTOL fuselage design. And also you can use the simulation software to study the simultaneous speed and also the landing strategy on the battleship or any utility application. Okay. Okay, so this is my talk today about our high payload drone in our lab. I think that many people are first time to have such kind of lesson, but it's no harm for you today that in the coming future we welcome you to come to our lab to have a look of the drone. Even if you have more interest on this kind of project, we also can invite you to join the project. Maybe also possible for some graduate student here. So as long as you have your topic and your available time, we can have more talk about that. If you want to have your study topic about the utility drone, about its control, its design, about the structure, about the power system, or something about the such kind of utility drone system. Okay? So this concludes my presentation. Thank you for your participation, and I welcome any question today. Thank you.
Okay, thank you, Dr. Kang. Okay, notice there's a few words there is confidential document, do not copy or distribute. Is this true? Because I took several photographs, so I just want to make sure. Is that okay or?
I think that today I think that for this for this class I think that I can share the slide for you all.
Okay, all right. Okay, I just want to make sure.
Restricted to a certain audience.
Okay, all right. Okay, thank you. Okay, whether or not you are first time to have an idea about eVTOL or the drone application. Anyway, we open for question Q&A section. Anyone has a question to ask Dr. Cole? Anyone? Come on, participate in the class. 大家尽量发问，好不好？不管你用中文、英文发问都没关系。记得也要回去写报告的。所以我刚看有人睡着了，来我看看你到时候报告是怎么写啊？我专门是上面 copy and pass 或抄袭不予记分。所以 OK, any questions? If not, I have a couple of questions. First, it happens I have an opportunity to cooperate with a sector team in the United States for the design of fuselage for eVTOL. Okay, but it's still in process to discuss the project. I just want to know what is the situation right now in Taiwan, progress in eVTOL. Other than E3, some company developing eVTOL, or as you said that it's very dangerous from takeoff and transition to cruise mode.
Yeah.
What is the best solution for this?
Okay. Except for the 4+1 power topology. Another typical one is we said 2+2. The 2+2 propulsion topology is that you have two tier rotor in front and the two fixed rotor in the back. Okay? So you also have four rotor, but these two tier rotor can have very strong yaw moment. Yeah. Because for transition stage, it is very important to diagnose the wind direction. Where the wind comes, and you have to move your plane direction just toward the wind direction. Then you can have takeoff. Okay. So if you cannot have a yaw manipulation at gust wind situation, then you will not have you cannot succeed transition stage. Yeah. But right now, there is a company in Kaohsiung, a very brand newcomer in this field, because they specialize in drone GIS. But they recruited several software engineers, and right now they have their scale model about 1.2 meter wingspan, and they have 2+2 design. And from my observation, they have very quite successful development. And for another company in Taipei, the most experienced one called Taiwan UAV company, 智飞科技. Okay, 智飞科技 are more than 20 years. Okay, for 智飞, they have the 4+1 design, so they can sustain at 5 to 6 Bureau wind ratio, wind level. Okay, so they have to improve their wind gust control. Yeah.
Hummingbird.
Yeah.
I'm not sure about because I have been visit the company and they show me their prototype. Okay, I saw the prototype hovering inside the building.
Yeah.
And I saw the video they have the field testing.
Yeah.
And some people say it's totally violating the aerodynamic, but it's actually hovering and actually flying. So I'm just wondering, what do you think about the hummingbird technology? Is that a successful design or?
So far, I'm not the right person to comment, because I have a project 3-4 years ago together with Hummingbird, and we have an exhibition in Nangang. They have their scale model, like 124. The scale model have very good flight, but it's not called the successful transition. That is because they keep too much attack angle, too large attack angle for their cruise mode. So usually we do not call it the successful transition. You can have the equilibrium. You can have stable flight, but it's not successful transition. It's not the right cruise mode attitude. Okay, but they actually can take off and have some extent of transition. Okay, for scale model. But it's very hard time for Dr. Lin these years. Yeah.
Any question? Any ask? Yeah, Michael.
I just want to ask about the difference between the EDF and the conventional propellers as well. Because I've been researching on the body types to use in eVTOLs, And I would just like to add, is there like something different if like the toll that the vibration frequency of propellers versus EDF rotors would be any different? Like maybe the vibration frequency for propellers, or which has like the more stress that could apply to the frame of an aircraft, EDF or propellers?
Yes. Usually, if you want to use EDF, you will have the embedded design. You want to decrease the drag coefficient, right? But for EDF, you have higher rotational speed, so you of course you have higher resonant frequency, but the most important or critical issue for EDF right now is that how to keep the reliability or efficiency for the propeller or motor, okay? Because at that higher rotational speed, you will generate a lot of heat from your bearing system, from your motor inside, but you usually do not have very effective cooling for your motor, okay? So, and also, if you want to design a very successful EDF, and you will increase some weight from your duct, because this will contribute about 30 to like 35 percentage to your total thrust. So, like Hummingbird, for their real scale ducted fan, it becomes very heavy. Okay. Then they just found that they cannot achieve such kind of thrust ratio. I mean, the effective thrust delivered with respect to your self weight. But for the traditional propeller, it's quite easier for you to achieve a very good thrust ratio. But for the speed, you usually you will have two you have 2 times or 3 times of the rated output. Okay. But for this kind of ducted fan, sometimes you can have 4 or 5 times if you can increase your speed. It depends on your motor design. So, do I answer your question, or you have? I have some.
It's actually on point out there.
Okay.
Right, good. Guys, any other question? You cannot expect Michael X every time. Okay, you have to focus on the talks. Again, try to participate in the talk if this situation pass. Okay. Right? Anyone else? 还有没有其他同学？没有关系，在学习过程当中。
我可不可以问一下，有玩过空拍机或者任何无人机或者玩过航模的同学，可以举个手吗？
Anyone have been playing around drone or anyone? 表示 anyone 你们都没有人玩过？
航模也算，remote control 的也算。
都没有玩过。那下次有机会我们找机会真的来机械系玩一下这种东西。我们找还有那个我们普玩系，we have faculty as civil engineering. They use drone for surveillance of the geostructure whatever. They play around drone. 大 also play about the drone. So maybe we'll arrange some time to play around. I think civil engineering is the best lecture that they are giving our university. Okay, now we'll see. Maybe we can arrange for that. 都没有玩过。不过我们有在土环系有老师他们在做那个无人机在做一些观察，那有开课，实际上机械老师也跟他合作在这里。对。OK。Anyone else？ 还有没有其他老师同学有要分享 ？Yeah， no one. Okay.
If we achieve efficient and successful eVTOL flights with the purpose of commercial flights, which is safer? A cab, a car, I mean riding in the daily traffic, or the eVTOL? Like, what do you think is more safe? If we assume that the price points are the same and everything is the same, which would be safer?
I will give you a compound answer. The first answer is that the eVTOL will be safer with respect to the traditional helicopter or traditional personal aviation. Okay, because they have more autonomous control function, and also you can have manual mode in special situations. So, of course, you will have a safe flight experience. And for FAA or other regulation, right now they are very, they're doing very much examination of such kind of application case. For their standards, they also have very high, like a 7.9 or 8.9. Usually we set 7.9 or 8.9 engineering reliability for such kind of eVTOL for its component. Each component they have to pass the very strict examination at the same level of the traditional airplane. So I think that it will be very safe, and also they have their flight altitude at as low as like 200 meter or 150 meter. So, and also they have their emergent pop-up rescue solution. So it becomes more safe with respect to traditional flight experience. Maybe.
So actually, there's a company that run for the eVTOL for personnel mobility right now.
Yeah. Like Lilium, like Joby. Like Joby Aviation in Japan and Lilium in Europe.
And the personnel inside the cockpit.
Yeah.
No control, right? The control is all.
Yeah. Right now the control is remote conducted by.
Okay. Any question? Any more? OK， 如果没有的话，那我们是不是在感谢我们彭副所长带来的一个精彩演讲，好不好 ？OK，Thank you
Thank you everyone. 谢谢大家。谢谢。
Remember you should have a technical report due on Friday night. OK, no time yet passed. 星期五要把那个报告上传。